Hi, we're going to cover a few basic cost concepts to get us up to speed on some of the terminology used in particular. It can be confusing. The same cost can be categorized in many ways. Same thing with revenue. There can be multiple ways of categorizing revenue. For example, think of a book in the library. It can be classified as either hardcover or softcover. It can be classified as fiction or nonfiction. It can be classified as autobiographical or just biographical, that kind of thing. So we could have a single book classified in many different ways, depending on what lens, what perspective we're interested in. And the same thing applies for costs. These are terms that are historical. They've been defined, adapted, changed, updated, refined over the centuries by accountants, people who take into the business of recording the expenses, the costs that we incur on our organizations, businesses, as well as the revenues. And so they come up with different classifications, different ways of looking at things. And these do help from a management perspective to be able to look at the kinds of things that make your decisions better, the kinds of areas where you're likely to make more of an impact with your decision. Fixed costs, those are the kinds of things that have no real relationship to the output, the activity, in the sense that as the activity level changes, the fixed costs will remain the same. So, for example, let's suppose we have a manufacturing facility. The insurance for it, it's going to be paid monthly, but it's going to be paid every month the same amount for the year, and it's not going to vary based on whether we manufacture, for example, 10,000 cans of paint this year or 10 million cans of paint. It really doesn't matter. The insurance is going to be the same for the buildings and all of that. Certainly administrative salaries, whether we manufacture, again, 10,000 or 10 million cans of paint, we're still going to have to pay somebody at the reception desk. We're still going to have to pay for someone to do sales, and all of those things are typically what is classified as a fixed cost. Variable costs, they change based on how much output we do. Obviously, we will need a lot more material and labor if we are going to manufacture 10,000 versus 10 million cans of paint at our production facility. There will be, obviously, the simple thing, we're going to have to purchase either 10,000 or 10 million cans from somebody. So that would be a cost, obviously. And then the material, the chemicals that go into that would also be quite different if we were doing 10,000 versus 10 million. And the hours of labor, if we had fixed equipment that was used to produce that paint, obviously we'd have to have a lot more hours of labor of people watching the machines manufacturing the paint for 10,000 versus 10 million kind of thing. Even if we had really fancy, very quick machines, there's no question the labor would relate to the volume of output that we were actually producing. Incremental costs, they're anything above and beyond the normal, in a sense. That's the easiest way to look at it. So, for example, if on our paint facility we operated the machinery from 9 until 5 every day, Monday through Friday. But then there's a customer has made a special request. They need so many thousand cans of a particular shade of color, and we decide the best way to handle that is to have the staff come in and do that on an overtime basis on a Saturday, for example. Well, the costs associated with doing that extra run, that extra day, would all be considered incremental costs. There would be some variable costs. Obviously, there's material and labor involved in that Saturday shift. They would be both variable and incremental. And there would be some fixed costs that could be associated with that overtime shift. So again, we can classify things in many different ways. They also look at direct costs. That's a term that comes up in accounting, and indirect costs. So indirect costs and fixed costs are kind of related in the sense that the indirect costs have no they're a cost that the company or the organization has to spend versus a direct cost, which might be if we had different facilities, different kinds of things we made at our plant. Maybe we have a building that's devoted to making paint, and we have another building that's devoted to making urethane or some other type of product. We would be able to have the costs of the electricity for the building that was making the paint. We could direct those costs against the paint production versus the electricity for the lighting and heating that was going to manufacturing the urethane cans. And again, so we can direct costs based on the specific output or work activity, and there would be some indirect costs that we could associate. The property taxes, for example, for the entire facility, we might proportion those based on the square meters of the building that does the paint versus the square meters of the building that does the urethane. Maybe one's much larger than the other, so we would allocate costs based on the volume or size of the building. So there's many different ways we can categorize costs in business in general. We will typically looking at fixed and variable costs as the kinds of things we're going to describe mostly in the course. But there are other descriptions and other ways of describing in a sense, an accounting way of looking at different costs associated with projects, operations, anything. And engineers will become, as you work in an industry, you'll become familiar with how that industry allocates the costs, whether they become a fixed cost or a direct cost. The terminology will start to become more familiar with you as you work with it, of course. In an accounting sense, we also have cash costs. These are things that involve an actual payment. So when we're purchasing those empty cans that we're going to put our paint into, well, obviously there's a cash involved, even if, nowadays, of course, all these things are done with electronic payments. No one wanders around with suitcases full of money anymore, but it's called a cash transaction when you move money from your bank account and you send it to the supplier's bank account. That's a cost transaction, cash cost transaction. Book costs, again, things that go on the books. Cash would be something that would show up on the accountant's books, set of books. They call them books because, of course, originally they were, a set of bound books with pages in them, and you used to write in them with ink the amounts of money that you spent, the amounts of money you received, that kind of thing. And so they're called an accounting book. And there would be, of course, the things that you paid cash for would be accounted for in those books. But there are also other book costs that you don't pay for. And the classic example, of course, is depreciation. And we're going to talk about that more in the second module where we talk about replacement analysis, and we talk about taxes and things like that. Things do depreciate, equipment depreciates over time, and the government allows you to deduct the depreciation as a cost. So as things wear out, you can deduct some value from the books that identify how much the equipment has depreciated. But you never actually pay that to anyone. It's not an actual cost that you send an electronic funds transfer to anyone. You don't send the money to the government. You don't pay it out of your bank account. It is a cost, though, and it is a legitimate accounting cost. And so it would be a non-cash cost that shows up on the books. Sunk costs, these are decisions made in the past. And if you were involved in that past decision to buy that piece of equipment, you might have some emotional attachment to the reasons why that particular piece of equipment was chosen, and you may have all kinds of, again, emotions attached to those decisions. But from an engineering economic perspective, sunk costs are not something that have any value to us. There's not, we don't account for them, we don't deal with them. They are in the past. And the reason for that is you can't you can't undo some of these sunk costs. You can't change the decision that you made 2 weeks ago. We don't have Harry Potter magic wands that we can go back in time and change decisions. So if you decided to, for example, have a piece of equipment delivered that's an upgrade to something that's already at your plant and facility. However, it's much larger, has bigger capacity, and the delivery door, the bay doors at the back of the building aren't large enough. So you have to go and make them larger. So you hire a subcontractor, and they would come and they would, make the doors 3 feet larger. Well, you can't unmake those doors larger if you decide that, okay, in the end, I don't want that piece of equipment. It's too difficult to work, it's too challenging, the manual's too complicated, the parts keep breaking down, so you decide to return the equipment back to the supplier. Well, you can't make the door smaller without spending more cost. It's not like like with the return of the equipment, the supplier would then credit you on send you money back in your bank account because you've returned the product. You can't do that with the sunk cost of expanding the doors, that kind of thing. So we always ignore sunk costs. There's only one exception, and that's to do with replacement analysis that comes up later, where we will look at that sunk cost as a way to estimate the value of something today. And that's the only reason why you would look at sunk costs, is if you're trying to use it as a base for estimating something. But you certainly never include the sunk costs in any of your calculations, and they do not factor into any of our decision making. In engineering economics, it's a forward-looking process. We look at what are things worth today and how are we going to make changes, either by adding new equipment to it or changing the cost picture by being more efficient. There's a whole series of things we can do going forward, but sunk costs are a backward thing, and we do not include them at all in our calculations. Opportunity cost, again, it comes up in the second module of the course where we're talking about replacement decisions. It's the typical example is you have some piece of equipment that's worth a certain amount of money, $5,000 today, for example. And if you choose not to sell that equipment for the $5,000, you choose to retain that equipment, well, then in a sense, you've lost the opportunity to make that $5,000. So while it's not a cash cost in the sense that you're paying out that money, it's an opportunity cost. So it's another way of looking at a non-cash cost and saying, okay, so if I choose not to sell that equipment, I've lost that opportunity. So in a sense, it's an opportunity cost. It's kind of a way of saying, well, and certainly it comes into play when we look at replacement analysis later on, that it says, yes, in a sense, I've foregone that revenue. So in a kind of convoluted way, it is a cost. Again, it does come up later on in terms of our analysis of replacement decisions. Big thing these days, certainly engineers are becoming much more aware of how the impact of life cycle cost must be taken into account in our designs. At one point, years and years ago, certainly in my youth, it was somebody else's problem to look at what the material, how it would be disposed of. We at that point hadn't really become cognizant of the impact that our designs have on the environment. And of course today we know there is a difference whether we make a design choice to have something manufactured out of steel or aluminum or titanium or carbon fiber or plastic. Each of those has a life cycle implication in terms of what it's going to cost. Some of those materials are, of course, more recyclable than others. Some of those materials cost a great deal more to manufacture, to produce, use a lot of resources to extract from the ground or to acquire, and also disposal. Some of the material choices we make today in our designs might have disposal costs associated with them 30, 40, 50, 60, 100 years from now. And of course, as responsible engineers, we need to take that into account. And we need to look at the total cost of our designs, not just simply today's costs. And this is kind of looks at the relationship over time. We have, at the beginning, based on our design choices, we have many different choices we can make. Again, you could make something out of steel, aluminum, plastic, carbon fiber, titanium, whatever the material choices. A lot of those have potential lifelong cost savings, depending on how they're recycled, what they can be used for again, are they a one-time use, all of those things. So certainly at the beginning of the project, as we're coming up with our design and making choices, there's a great deal of potential for cost savings. Once our design is built, once we have made those decisions and committed to a particular material choice or committed to a particular manufacturing process or committed in the sense of how our design is going to be used, once we've made all those decisions and the product or the design has come to fruition, there's no more potential for cost savings. Once it goes out the door, certainly there's some potential, small potential as it's being used, but basically certainly the cost, the potential for savings is gone because we've already made all the choices, and now it's a matter of the clock running out in terms of that total life cycle. And the cumulative committed, and the reason for discussing this is that often when we're doing designs for large buildings, for example, we often will negotiate with subcontractors and get contracts going before the final design is produced. We'll start to say, okay, well, we know we're going to need so many tons of concrete, or we know we're going to need so many electricians or plumbers, and we will start to set up contracts. So if I want to start construction on my new apartment building at the beginning of June, it might be necessary for me to line up the subcontractors that I'm going to need in January and make sure that they mark in their calendars that they're going to be coming to, my place, the 1st of June to start construction. And I might need to enter into contracts with the equipment, for example, backhoes or other scaffolding or cranes or whatever that's required for the production. I might need to actually sign contracts beforehand to say, yes, I'm committed, you're going to have so many hours of work. Well, those committed costs get signed up early in the cycle, and usually with those kinds of contracts, there's a penalty clause if I back out, and so it does cost me something, even if I maybe don't make the payment in terms of actually signing a check or sending some money across to someone's bank account for their labor, because I'll do that when the construction starts and they've actually expended the labor. But in many ways, I've committed to spending those costs long beforehand. And so it can be that and that's part of the reason why, of course, the life cycle costs, the potential for cost savings decreases fairly quickly over time, because I'm committing to, certainly for the large projects, committing to making cost expenditures early on before I actually pay for the labor or pay for the materials. I've made a commitment that I will. in order to make sure that my project management lines up, that those materials are available to me, that the labor, the individuals will show up at the job site, that they will be available for me when I need them. And there's no question there are implications that when we start to analyze this, and part of the challenge with the costs of a failed engineering design is it's better to spend the time thinking about it and getting a good design up front, because once we start the actual process of negotiating those contracts and starting to set up the suppliers and things, our costs start to go up, and if the design fails in the end, it doesn't mean that even if we haven't produced any plans for the drawings, it doesn't mean that there haven't been costs associated with it, right? Because there's no question the committed costs are coming in sooner than the actual costs throughout the design phase. And again, as I said, there are many things that start to, from a project management perspective, are required in order to get the job underway. This is basic economics. They call this the price-demand relationship, and typically as you produce more and more units, the price comes down. There is this concept called economies of scale, that as you do more and more, your fixed costs remain the same. However, and your variable costs go up by the unit, but now your fixed costs can be spread across more units. So if you have the same fixed cost and you're spreading them across 10,000 units, the total cost for your cans of paint will be much higher than if you can spread those fixed costs over 10 million cans of paint. The amount of fixed cost per can of paint goes down dramatically, and that's typically reflected in the price, the cost, the price of something. As you manufacture more and more, the relationships are not always linear, as shown here. This is a fairly basic model, but often for many types of products and commodities that we typically buy every day, this relationship does hold true, that the more and it's because typically the variable costs are linear as well, that if you're going to manufacture 10,000 of something, you need 10,000 cans. If you're going to manufacture 10 million, you need 10 million cans. It's not quite linear because, of course, as you start ordering more and more cans from the supplier, the price that you're going to have to pay for buying those cans is going to come down as well. It flows throughout the entire economy, this basic concept. And one of the things that we're not going to cover in the course are things that are considered exotic goods. So if you're looking for some interesting, fun, light reading over the summer, certainly I can recommend this interesting story about Bringing Home the Birkin by Michael Tonello. It's fun, lighthearted, but it looks at luxury goods, and it looks at the fact that the Birkin handbag, the way it's marketed, the way it's available, the supply of these very expensive products are constricted in such a way as to increase demand, to make the exclusivity. And in that kind of a realm, the same thing with anything high-end expensive automobiles like Maseratis or Lamborghinis that are handmade. These kinds of luxury goods don't follow the same basic price demand relationship. They don't follow the typical price elasticity models from economics. They are in a separate world in their own. And of course there are models that deal with that kind of thing, but we're not going to get into that in terms of our course. The types of things that the models and things that we're going to look at will all be for basic goods, commodities, basic projects, basic kinds of things that all follow or closely follow this basic economic model of price versus demand. One of the interesting outputs, if you look at that model, and you start looking at total revenue, comparing that to demand, there is a point where your revenue will maximize. And after that, as demand increases, typically the reason that the revenue comes down is because you have competitors entering the market. When they see that demand is high, you get competition, which means you're kind of forced, again, part of that price-demand relationship, you're sort of forced into reducing your price in order to remain competitive. Well, as that continues, you're taking less and less revenue per unit, which means that as demand increases, typically because of the economies of scale, because of competition, because of a number of underlying factors, as demand exceeds your maximum revenue, your revenue falls off. It is this inverted parabola that does follow. And again, this is for basic, common, the kinds of things we're going to cover in this course. Certainly not covering anything in terms of luxury goods, that kind of thing. And when you start to put these different models together, so the horizontal line is the CF is your fixed costs. The variable, obviously, as you produce more units, as you increase the demand for a particular, and you start manufacturing more cans of paint, your variable costs will go up on the same basis. You will have 10,000 cans to buy versus 10 million. The variable cost will increase. The cost per unit might stay the same, but the total variable cost will increase as demand increases. And when you look at that, when you put these curves together, the CT, the line, and this looks like it's about a 45-degree angle. It won't necessarily be at a 45-degree angle or anything, but that's for this purpose of this diagram. The total costs are the sum of your fixed costs and your variable costs. And when you look at this and you apply that to the total revenue picture, it shows you that you're actually going to maximize your profit well before you hit that total revenue maximum. And that's simply to do with visually here it shows you that at some point you will maximize your profit. And of course, to remain in business, to be viable as an organization, as a company, you're striving to get to that maximum profit, which sometimes means making decisions about not producing something. You may decide that it's just not worth doing that incremental extra shift on a Saturday because it really isn't going to help maximize your profits. It may in fact help reduce your profits. Now there are other things besides profit that get involved in everyday business organizations. Customer satisfaction, of course, comes to play. So if it's a very big customer of yours and they need a particular shade and you have to do an incremental extra shift, then that may not help towards your bottom line maximum profit, but it certainly might help in terms of your overall profitability, that you're maintaining a good relationship with one of your significant customers, that kind of thing. One of the things we look at quite often is the break-even point. Anything below the break-even point, you're operating at a loss. So again, we have the same fixed cost line that's horizontal, and the variable cost line, or the total cost, includes the fixed and variable costs, and it's at a slope. And if you look at your total revenue, you can also plot that against the demand, and you can see that there is a break-even point where you're making profit above the break-even point and you're making a loss below the break-even point. This is often very useful information. We'll get into it again more in the sensitivity analysis that we're going to look at in the second module of the course. But essentially, knowing where your break-even point is, how much, what your costs are at that break-even point, is useful information for negotiating with suppliers. Knowing that, for those empty cans, I can't afford to spend more than 25 cents. My break-even point is at 25 cents per can. And if the supplier says, oh, I'll sell them to you for 27, you can say, no, I'm sorry, based on my projections for revenue and all those other factors that go into it, your costing analysis, you can say, no, that doesn't make sense for me. I'm going to end up at a loss. My costs will be too high. So knowing what the break-even point is a useful piece of information, certainly from negotiations, but also from decision-making perspective, to know how many cans of paint. If I have these fixed costs and these are my variable costs, you can plug these things into a model and you can say, oh, hang on a minute, based on my cost projections, I need to be able to produce 12,000 cans of paint a month. Otherwise, I'm not going to be able to break even. I'm not going to be able to make a profit. And you might be able to identify that, yes, if I make more than 12,000 cans of paint per month, at all the other factors included, I then should be able to make a profit. And so again, useful information, certainly engineers in a decision-making role, that's often the case, looking at where the break-even point is, knowing in advance where the break-even point allows you to make quicker decisions, to be able to say, yes, we should go ahead with this production, or no, we shouldn't go ahead, that kind of thing. There is one special case that is covered in the textbook. It's called present economic studies. It's not something that we will use very often in the course. There are rare occasions in engineering where it does come up, where you can look at something over a year. And when you're looking at projects that start and end within a year, the time value of money isn't as critical. It's not unless interest rates are extremely high, which again are sort of outside the bounds of the type of material we cover in the course. But for normal, average interest rates, studies that are about a year can probably ignore the time value of money. And then it's a very simple analysis where you're looking to either maximize profitability if you have a sense of the revenues, and the revenues are varying between alternatives, so you're looking at maybe doing two different things with an empty piece of land, so you're going to have revenues coming in from different ways depending on whether you build condos or whether you turn it into an organic farm. You're going to have different kinds of revenues. So then you want to look at which operation, which alternative is going to maximize your profit. If, on the other hand, I've got the same revenue, so I'm manufacturing those cans of paint, I can sell those cans of paint for $25 a can. Doesn't matter whether I manufacture that same can of paint on my A production line or my B production line or the C production line. Then it's really about not worrying about the revenue. The revenue is taken out of the equations, and you're really looking at then minimizing the costs. Which set of machinery is my A production line going to be able to produce those cans of paint cheaper than my B or my C? And so you're just then looking at the alternative that minimizes the cost, making the cost the smallest possible, and then from that you could decide whether you want to use production line A or production line B. And that's it for the simple overview of economic cost concepts.